Creating a 2D game. Before you create a 2D game, you need to decide on a game perspective and an art style. To create a 2D game, set up your Unity project and then familiarize yourself with the relevant concepts in the following order. You should already have installed your software, so I already have mine here. I have a video showing you how to install the software, and I pretty much have this one, but you can also go here in the just Unity 2022 and you can create a 2D or a 3D template, and you're gonna see right now. So right now I'm creating a well, I have a 2D object, so this is the one Unity Hub. So you can go into new project and just pretty much pick this. I am here in all templates, so you can pick up 2D core, 3D core, 2D URP, all the stuff, so you can do that. And yeah, I'm choosing a 2D, and this is how it's looking up to this point. So I have the main camera and I have the 9 slice. So I have the main camera. I'm just gonna press F to focus it, and well, this is the game. I have also, if I go to the scene, I can click in the 9 slice and I can focus it. So we have this for now. So here we have the fundamentals, the scripting, and mainly we're gonna be deal with C#. So that's the code that we're gonna be writing. Okay, so we have the sprites, we have the building in-game environments, character animation, graphics, physics, 2D, audio, user interface, profiling, optimizing, and testing, and finally the publishing. So we have the fundamentals, so game objects, and here pretty much everything is a game object. So if I create a 2D sprites, it's gonna be a game object, physics object, tile map objects. So we have all this. Okay, so game objects are fundamental objects in Unity that represent characters, props, scenery, and more. Every object in your game is a game object. Game objects represent the items in your game. The space in which you place them to build your level is called a scene. Scenes in Unity are always 3D. When you make a 2D game in Unity, you typically choose to ignore the third dimension, the Z-axis, but you can also use it in special cases. For example, when you make when making 2.5D games, that pretty much is 2D games, but with some trickery with the camera, so you can pretty much it would look like a 3D, but it's not really a 3D, it's a 2.5D game. So the behavior of game objects is defined by blocks of functionality called components. The following components are fundamental for 2D games. So we have the transform, the sprite render, the cameras, the collider. Okay, the transform. The transform component determines the position, rotation, and scale of each game object and the scene. Every game object has a transform component, and let me see if I can. Okay, so we have that. We have the rotate here, the tool, we have the move tool, we have the scale tool. Okay, and right now we are just dealing, since we are dealing with 2D. Okay, but now if I unclick it, so right now we are dealing with 3D. Okay, so you can do that. We're gonna leave it in 2D for now. Yeah, that is for the transform. Every game object has a transform component. Now we have the sprite renderer. The sprite renderer component renders the sprite and controls how it looks in a scene. Cameras, devices that capture and display the world to the player. Marking a camera as a orthographic removes all perspective from the camera's view. This is mostly useful for making isometric or 2D games. Collider 2D. This component defines the shape of a 2D game object for the purposes of physical collision, see 2D. And for example, if you are building something similar to Mario or something like that, you would need physics, the way that the player is jumping and how it's gonna pretty much collide with another object, how much, because if no, you can just press, I don't know, the space bar and the player would just go up, but it wouldn't come down. So components are UI representations of C# classes. You can use scripts to change and interact with components or create new ones. See the scripting section for more details. So we're gonna be using a little bit of C# here, and yeah, you can use your Visual Studio Code for that. And let me see something real quick. If we go into edit and we go to preferences, let me see. Okay, so let me see animation physics. Okay, so we have all the style. Let me see general. Okay, so the theme editor. Okay, the front editor. Okay, so everything is good here in preferences. Let me check real quick in new projects, project settings. Let me see real quick, audio, graphics editor. Okay, so we have the Unity, GPA. Okay, so yeah, everything is fine here. Okay, so let's continue. Scripting. All 2D games need scripts. Scripts respond to input from the player and arrange for events and the gameplay to happen when they should. For details on how to use scripts in Unity, see scripting overview. Also, see the Unity Learn Beginner scripting course, so you can check out that. So you can click here and pretty much it's gonna send you to this link, beginner scripting. Okay, scripts are attached to game objects, and any script you create inherits from the monobehavior class of sprites. Sprites are 2D graphic objects. You use sprites for all types of 2D games. For example, you can import an image of your main character as a sprite. Okay, so there will be like a sprite here. Okay, so we have this image of this player. Okay, a character sprite. You can also use a collection of sprites to build character. This allows you to greater control over the movement and animation of characters. So as you can see, this player has, well, there are pretty much the face, the torso, some legs, the hair, a belt. You can see the arms, some clothes here, and here in the position you have the name, the position border, the pivot unit. So multiple sprites that make up the parts of the character display in the sprite editor. So right now I'm dealing with the, okay, so we have in the inspector we have the 9 slides as well as the main camera. And again, if you, okay, in the main camera we have the transform, and just here some information like the clear flags, the background, the cooling mask. Okay, so let me see now. Importing and setting up sprites. Import your sprites with Unity's recommended settings. See importing and settings up sprites. Rendering sprites. Use the Sprite Renderer component to render your sprite. For example, you can use the Sprite Renderer to change the color and opacity of a sprite. So in this case, they're giving us this example. And as you can see, we have this player here with this particular RGBA color. So this is will be for the red, green, blue, and alpha. And you can change the modifier. So this is in hexadecimal. You will have the F, okay, 6F. So you will change it to CB2, okay, CB2B2B. So, and they will give you this particular color. So adjusting the color of a sprite with the Sprite Renderer. Okay, so see the introduction to the Sprite Renderer Learn tutorial. You can check out this. Sorting sprites. By organizing sprites in layers, you can create an illusion of depth. You can sort sprites according to many strategies. See sorting sprites for full details. For example, you might sort sprites along the y-axis so that the sprites that are higher up are sorted behind the sprites that are lower, to make the sprites that are higher appear further away than the sprites that are lower. So okay, so they give us this example here, but if we go, let me see if we can just, I don't know, create a 2D. Let me maybe see. Okay, so let me see if I can move this one. So I can move it forward, I can move it backward. So we are in 2D, so I can move it in the up position. I can move it downward, so up, down, left, oops, left, right, and I can also do this. So as you can see, we are dealing with let me see, yeah, we are dealing only in the position, we are dealing only with the x and y coordinates. The z coordinates in 3D is not working, obviously, since this is a 2D game. Okay, so we have that, and this is still in the position of the camera, so if I move it away, so nothing is going to appear in the game, since it's from out of the side of the camera. So now I am pretty much in the center. Okay, like that. So we have this sprite sorted along the y-axis. So let me see something here. As you can see, we have the y-axis in green and the x-axis in red in this position. If you wanna just give it a try in 3D, we will have z, and this would be in the blue, but we're gonna stick it out right now in 2D dimension. So, and let me just focus it. So you just press F to focus it. Okay, so to set the overlay order of sprites, use the sorting layers to group game objects with sprite renderers and control the order in which they render their sprites, and use sorting groups. Sprite Atlas. You can use a Sprite Atlas to consolidate several textures into a single combined texture. This optimizes your game and saves memory. For example, you can add all your sprites associated with a particular character or purpose to a Sprite Atlas. So this is the example that they're giving us. Okay, a Sprite Atlas. See introduction to Sprite Atlas and tutorial. Now, building and game environments. Environment design refers to the process of building your game's levels and environments. You can combine the environment design tools in the section in whichever way makes the most sense for your game. For example, you can make a top-down game using only 9 slides, or you can make a side on platform with tile map or sprite shape. Okay, so right now we have, this is a 9 slice, and if you want to check it out in 3D, so this is how it would look. But let me see if we can check it out. Okay, so we are just seeing it in 2D here. Now 9 slicing, so this is pretty much what we have so far. The 9 slicing, or 9' slicing, is a 2D technique that allows you to reuse an image at various sizes without needing to prepare multiple assets. Unity can dynamically stretch entire designated parts of a sprite to allow one sprite to serve as the border or background for the UI elements of many sizes. See the 9 slicing sprites, for example. You can use a 9 slices to stretch a sprite to shape when you build a 2D level. So you would do something like that. So a 9 slice sprite is split into 9 sections. So we have the section, we have the A, just a little square, then we have B, this long rectangle, C, that is pretty much the same as A, and G and I is pretty much the same as A, a little square, and B, D, H, and F are long rectangles. So we have 3. So we have 3 elements, 4, 5, 6, 7, 8, and finally we have this big square that is E. So we have 9 sections in total. Okay, so you can check out 9 slicing for scalable sprites tutorial. Then now the tile map, and let me, oops, no, I didn't want to click that, but never mind. Okay, tile map.